purpose of this video is to go over the graphing problems on 1.5. If we look at 1.533b, and sometimes if you resize things, it might fit a little bit better in your screen. So here we're looking to graph a function that has a removable discontinuity at x equals c. In this case, the c is going to be 3. So this is stating the function, the limit exists, but it's not continuous. So the limit on the right has to equal the limit on the left. But for it not to be continuous, the value of the function at x equals 3 can't equal the limit because it's not continuous. So sketching the graph, if we pull what we have here, we have a ray. The little black dot is so you can change the ray's direction. So you can make it go left or right here. So for this specific function, we want to know that f at 0 is 2. So if I put this point at 0, 2, and then of course I need to deal with c equals 3. That's going to be where I have discontinuity at. So I can move this little black dot so it's at 0, 2. So my function evaluates to 2 when I plug in x equals 0. So if I go get another ray here, and I can move this point here, and I might want to put it at 6, 2, or it doesn't really matter where you put this black dot. The black dot is just so you can reflect the ray when you're given. The x point doesn't matter, just the y point needs to be 2. So the limit on the left equals the limit on the right, therefore the limit exists. However, we want the value of the function at 3 to be 5. So the value of the function at 3 needs to be 5. So I'm going to get this dot, and I should be able to zoom in. It should have some kind of magnet. If you put it like halfway between, it should put it at that point. So the value of the function at 3 is 5. So this should be everything we need for this function. If I go ahead and submit this answer, it's going to think about it and then tell me the answer there. If we go to the next graphing problem, this is 7C. In the same homework, we want to graph a function that is not continuous at 5, but it would be continuous at 5 if the value was changed f of 5 is 7 to f of 5 is 2. Then it would become continuous. So it's the exact same approach, except our x value is at 5. If it was changed from f of 5 equals 7 to f of 5 equals 2, then we would have a continuous function. So the x value is 5, the y value would potentially be 2. So I'm going to set up the same kind of idea. This is what it looks like to have a removable discontinuity. Put this one in here, put this one on here, shift it this way, move this down. And just depending on what you're using, I have my laptop and it's kind of making it difficult to use. I need to get a mouse out. You can zoom in. Sometimes zooming in makes it a little easier to deal with. So my y value is 2 there. My y value here is only 1.9, so that even though it looks what it should be, let me put my point at 5.2. And then we put this point here at 5.2. Okay. So f of 5 is 7. This is an example of a removable discontinuity. The limit exists, but the value of the function at that point doesn't equal the limit, so it's not continuous. So 3 things have to happen for a function to be continuous. The limit on the right has to equal the limit on the left, has to equal the value of the function at that point. Removable discontinuity means the limit exists, but the value of the function at that point isn't the same as the limit. So here they're saying sketch a graph of a function that's continuous, that's not continuous at x equals 5, but would be continuous if I change the value of the function from 7 to 2 at x equals 5. So again, scroll down here, submit answer, and that gives you that. So hopefully this is helpful. If you have any other questions, please let me know.